Uh, Hi, today in this YouTube video, we are going to discuss about different ways to establish communication between Spring microservices. We all know the microservices architecture is the very good architecture, and nowadays all the modern uh, companies applications are being used by the microservices architecture. They're using microservices architecture instead of monolithic because the complex applications can be built, or their requirement can be achieved through microservices architecture. But when you are building microservices, right, you will have number of microservices, thousands, tens of thousands of microservices. You will have thousands of microservices if it is a complex applications, right? You may have 100, 200, or 300, 400, 500, 600, 700. You can have many as many number of applications depending on the size of the project, right? You can build complex applications. But how do you establish the communication among the microservices? It is a problematic thing that will arise when you are building complex application using microservices architecture. Because if you are building multiple microservices, how do you establish the communication? How one service can communicate with other service? How do they communicate? How it is possible? You know, when two services are communicating, there may be a chance you can get a latency between the request flow when the request is floating floating back and forth, right? It has to go to the server and it has to fetch the detail. After that, it has to return the response to render that on the UI. So how is it possible? It can be possible. We can actually do it using HTTP, but APIs will come into the picture when you want to communicate with the different types of data structure, right? So there are two ways of communication. So the first thing is synchronous communication. Second thing is asynchronous communication. Synchronous communication, the calling service waits for the response from the called service before continuing execution, right? If service A is calling service A has to wait until the service B gives the response to it, right? It is called service the synchronous communication. So under the synchronous communication, the first way of establishing communication between two services is REST template. The simplest way to establish synchronous communication between microservices is called REST template. You see here, I'll explain the REST template, how we can use it, because so it is a REST template is a predefined class. You can actually import it and then you can auto-wire the REST template. It is going to have multiple methods. We are going to pick get for object method. See what we are doing here. For this particular method, get user orders, and inside that we are passing ID. We have used the path variable instead of the request parameter. See, then what we are doing here, we are concatenating that ID for this particular URL, and what it will return, it will return data of type string, right? So what did we do? See, ID, and its type is a string dot class. Okay, string dot class, we are passing the ID of type string. So we need to specify the URL and the type. So we need to pass these two parameters for get for object method. And then what it will do, REST template, we are going to see, first we injected this REST template and then we actually pass these two parameters, and REST template dot get for object will return the data automatically. Okay. So the recent thing is Just like a REST template, Spring is recommending web client for new applications because it is um, improved method of establishing communication between services, just like a REST template. Web client will allow you both synchronous and asynchronous style of communication as well. I'll explain that later. But you see, under the synchronous communication, the second category is the fin client. Fin client. So, what is fin client? Is a fin is a declarative HTTP client that simplifies the inter-service communication by letting developers define the REST calls using Java interfaces instead of boilerplate code. Here, what we will do, we will create a Java interfaces, right? We will use the Java interfaces and we'll specify the what kind of service we need to call and what is the service name, the host details. We'll specify all these things. See, we are going to create an interface, public interface, order client, and we have some method here declared, get order method of type returning output of type string. Okay, and here we mark this particular interface with the fin client, name equal to order service, fallback equal to order client fallback dot class. In case if any issue occurs, so the respective fallback method or class that is going to execute, we need to specify that as well. If it is a microservice based architecture, we need to take care of the proper fallback mechanism as well. In case if the service is not returning a response, or if it's failed, it has to return some fallback response. That is why we use fallback concept. It is a different concept, we can discuss that in other video. There are different ways we can actually create a resilient of microservices. There are resilient 4J and fallback concepts, circuit breaker mechanisms. So many concepts are there. We will discuss them in other videos. You can see here, and fin client we have given order service. The name is order service. Now, now you see, now we can actually use this order service directly in other service when we want to call this particular service, right? You can see here, provides the alternate response. Where is this order client? Get order, return order service enable, try later. You see, provides an alternate response when the remote service fails, ensuring graceful error handling. This is regarding a fallback, right? We need to have a fallback. Okay, see, the thing is here, the interface, this is the main thing. So when you want to call particular order service, you can directly use its name. Okay, use its name. You don't need to specify the local host, all these details. You don't need to auto wire anything. Simply use this interface and call it. Okay, fin client connects to the order service. If the service enables fallback class metric get. It is very simple. So that way you will define, you will create a interfaces, fin client interfaces, right? For a particular service, you can directly call this particular client. Have you heard about the stubbing concept? Earlier days, whenever we are going to build a SOAP web services, we will generate a client stubs for SOAP web service. We use those stubs for communicating the SOAP web services, right? Because we need artifacts, those artifacts, all those stubs. We use those objects. Simply we will establish a communication using those stubs. We will generate the stubs using a digital file, right? How do you generate, how do you call particular SOAP web service? You will generate a client stubs for using a particular digital file, and then you can call that particular web service, right? The same way you are going to create a fin client interface for a particular service name. You will just use this service to call the particular order service. So this is another way, second way of communicating among the services. You can see GRPC. GRPC remote processor call. This is actually developed by the Google. GRPC is a high performance open source RPC framework developed by the Google that enables efficient communication between distributed services. It uses HTTP by HTTP by 2 for transport and protocol buffers for fast and compact data. Serialization making it ideal for low latency and microservices. Okay, this is basically developed by GRPC. This protocol was this kind of communication was implemented with the Google. So what I'm doing here, I'm going to explain how we are going to use it. You can see here. You can actually see here managed channel equal to managed channel builder dot for what we are doing. We are using localhost comma 9090. We are giving the localhost details and the port number. What kind of data we are going to use for communication? Plain text. Dot use plain text build and order service grpc dot order service blocking stub. Okay, and stub equal to just simply sudo some simple code snippet, not full code, but you can see order service grpc dot new blocking stub channel. We are passing the channel. Channel contains the managed channel on which this service is running. It is running on localhost 9090. And order response, you see order response equal to stub dot get order, order request new builder, and set id 123 dot build. You can see here respond dot get details. And now you see managed channel builder for address. Create a gRPC communication channel to connect the client with the order service running on port 9090. Okay, and order service grpc dot new blocking stub channel. Stub dot get order. See here sends a request containing order ID 123 to remote grpc service, receives order response and prints the order details to the console. So there are three ways we discussed so far. Among them, gRPC is a high performance open source RPC framework. It is, efficient communication can be established between distributed services using gRPC. That is why you can opt for the gRPC if you want high performance and very efficient communication need to be established among multiple distributed services. You can go for gRPC. Otherwise, you can use it is a microservice. You want a standard approach of calling these services, you can use a fin client approach. Otherwise, REST template. Spring is recommending the web client. As I told you, web client allows both synchronous and asynchronous approach of calling. We can discuss that in another video. You can see here. Another kind of communication is asynchronous communication. You see here, this is asynchronous communication, message broker approach. What do you mean by asynchronous communication? Asynchronous communication means the service do not wait for the immediate response. Instead, messages are exchanged through intermediate system. Okay, allowing services to remain loosely coupled. So message broker are middleware system that enable application service to communicate by sending and receiving messages in reliable and asynchronous way. You can see here we are actually creating a consumer auto consumer. We have used we marked it as enable binding sync dot class stream listener, because it is a listener. It listens to the topic or the queue for particular event. If message is published to that stream of a topic or it listens to that. That is why we can also call it as a sync class. You say binds this class to input channel sync input, so it can consume message from the message broker. So order consumer acts as a message consumer listening to the incoming order events. You see here address stream listener tells the Spring Cloud stream to invoke handle order event wherever the message arrives for the input channel. So this is one of the ways of creating a consumer class. You can use multiple ways. You can actually use Kafka as well. You can use RabbitMQ. You can use some other messaging softwares. So you can actually use Spring Boot with any other third-party messaging software to create a event-driven architecture. You can create event-driven architecture using those ways. Okay. Now the second thing is Spring Cloud Bus. Okay, Spring Cloud Bus is a framework used to link multiple microservices with a lightweight message broker to share configuration and state changes. It helps propagate event across distributed system. Okay, you see, uses a message brokers like RabbitMQ, Kafka to broadcast events, commonly used to refresh configuration across services dynamically. Generally, when we use the Spring Cloud Bus in enterprise applications, whenever you want to refresh a configuration across services dynamically, um, what do you mean by refresh config? Means you have multiple uh, Spring Cloud Bus, right? So you have multiple services and you want to generally uh, update the configurations dynamically, then you can use the Spring Cloud configuration also. That is one of the use case here. See here we create a bus refresh control and then application event publisher. It is a publisher and refresh config. What we are doing, publisher dot publish event new refresh remote application event. This config service, we are triggering the config service. Whenever you actually call this particular endpoint, it will actually trigger the config service, right? So immediately this publisher will publish the config service. That config service will update with respect to all configurations, right? It's a simple use case actually here. You can see here. This is one of the ways of establishing communication under asynchronous communication part. You can also use the Kafka and other third-party messaging softwares. So let us see the comparison between synchronous and asynchronous communication. Coupling, when we talk about the feature coupling in synchronous way of communication, it is very tighter because the service has to wait for the response of the other service, right? There is a dependency, which is why we say it is the coupling is a very tight coupling, right? A service A is dependent on the service B, but asynchronous approach message and broker bus is the loose coupling. And feature latency, a caller waits for the response. Latency will be very high in case of synchronous because the caller has to wait. In asynchronous, the caller continues immediately, right? They don't need to wait because it follows the asynchronous mechanism. Once it publish a message, immediately it can go for a next instruction to be executed. It does not need to wait for the response. So once you publish the response, that will go into the queue or topic. Whatever the consumer classes they are subscribed for that particular topic or queue, they will listen that particular event, they will consume the data. The complexity, you can see, when we are implementing this kind of synchronous approach, the complexity is very low, yeah, because it's very simple, straightforward, you can implement. But when you are implementing synchronous, complexity is very higher. Let's say if you are pushing multiple messages, in the middle somehow something is broken, You have to make sure the order of the messages. In case if some messages are lost, how do you actually tackle that issue? So these things are very critical when you are going for asynchronous. You have to make sure you need to store the each and every message that you are consuming, whatever the message you are publishing, into some persistent storage, so that you will not miss the track of those messages. There is some complexity when you are implementing it. So use case, request response workflows is very simple. For asynchronous, it is event driven decoupled workflows. Okay, it is event driven decoupled workflows. Reliability is depend in synchronous approach dependent on the service uptime. Let's say the service A is trying to call service B, but the service B is somehow down because of some issue. It is not responding to the service one. And reliability, how reliable that is service A, how reliable the service A is, because it depends on the service B. It depends on the other service uptime. If other service is up and running, then it is no problem. Otherwise, it would be a problem, right? So the second thing is in the reliability, it is more resilient with retries and buffering. So this is the concept, retries and buffering. In case if the message is not consumed, we can also retry and buffer. We can use these concepts to make sure that messages are published properly and retrieved on other hand with other side with the proper details. So this is how the communication among services can be established. There are so many ways actually. We discussed only few, but there are so many ways in the market. Even the new frameworks are getting introduced. To simplify the communication. They are actually providing the features for both synchronous and asynchronous communication. Nowadays in the market, for most of the applications, for building complex applications, the teams they prefer to use both synchronous and asynchronous communication depending on the requirement. So they will prefer to use both the architectures in single project. There are possibilities because they are preferring to do like this. For notification kind of modules, you need to use asynchronous communication only, right? Okay, this is about the synchronous asynchronous communication. Thank you for listening.